Welcome again to my class. My name is Amara. I am the physics teacher on Akadastor. Today we continue our investigation of electrostatics. Um, in your notes, I asked whether you've ever touched a door, the doorknob, and then you felt this electric shock. And you kind of wondered what happened. That's actually electrostatics in action. Now remember that all lesson notes, discussion, the question and the answers, and all the tests I'm going to be sending, I'm sending them on Akadastor. Okay, so for this demonstration, I'm using FET simulation for this demonstration. Now this is a guy, right? This is a carpet. And from the first simulation we did on this particular subject, electrostatics, we said uh, this mat is neutral. Apparently, the man is neutral. The doorknob too is neutral because there are equal numbers of electrons and protons in each of them, so they are at rest, neutral. Now, watch what happens when this man he this he gains electrons. Now, remember I said that when two materials rub together, one has a higher tendency of losing electrons, while the other has a higher tendency of gaining the electrons. Now, the one that lost electron becomes positively charged, while the one that gained the electrons becomes negatively charged. It has a net charge of negative. Now, so this man has rubbed on this mat. The mat lost electrons to this man. So the man is now negatively charged, even though he doesn't know it. Now, watch what happens. This door is um this one is stable right now. There's no net charge, equal positive and negative charge on the door, so it's stable. Now the man comes and touches this doorknob. What happens? There's an attraction, right? This is negatively charged. If you remember from the first demonstration I made, this is negatively charged. The man is negatively charged, even though the door wasn't charged. It didn't have a net charge. But because this one had a negative charge and it touched it, the tendency was that it lost electrons to the door. Now, if it's high enough, it's going to give me some kind of zap or shock, right? Now, in your lesson notes, I mentioned, okay, let me just give you the answer. I mentioned three ways of charging an object. There are three ways. I'm not going to mention them here, but I want you to, based on this demonstration, you identify which is which. Now, the man rubs on this, it becomes charged negatively, right? Then he touches this.
Ouch.
Now watch what happens if I wait, hold on. This. Watch what happens. If there's a lot of electrons in this man, just watch what happens.
Ouch.
He didn't have to touch the doorknob, and yet there was a zap. He still lost electrons to the door. He didn't have to touch it. Let me just show you that again.
Ouch.
Okay, so this is where grounding comes into place. We'll discuss that in our further class. So what do you think? Which one is which? This charging, the one that touched it, and then the one that it didn't have to touch, which is which? So I'd like you to, based on your lesson note, you should be able to identify which is which. Now I also have a podcast on the various ways and methods of charging an object. The idea is that you listen to it. The discussion between the panelists helps to drive home these things. We're not trying to cram here. We're trying to understand how physics works, how things work. And if you can understand it, it's fun. You actually see that you deal with these things in your everyday life. It's not just about quoting formulas and you're trying to cram it. No. Once you understand this, you understand it. So you listen to the podcast, like I said, that will buttress some of these points. I don't want to be overloading you with lesson notes. So the ones I feel it will be easier for you to understand with such methods, I will make it available to you in that method. Okay? All right.